The second type of category is about analytics data. As part of the digitization wave, more and more companies rely on analytics data to make ongoing business decisions by querying historical data and looking for trends over time. It is considered to be the input for business intelligence, BI. For example, grouping all customers during the last year based on market segments or presenting the top 20 products sold in the previous month by customer between the age of 40 to 50. In many cases, analytics data is based on the same operational data but in a much larger scale, meaning much more data. This kind of high-level aggregated analysis helps to tune the business, focus on emerging new opportunities, identify trends in the market, detect anomalies, and much more. On one side, we have operational data handled by OLTP databases. A group of OLTP applications is constantly updating the databases with online transactions. On the other end, we have analytics application that would like to access this data, but differently, while running more complex reading queries on the database for aggregated analysis. One option will be to store and handle operational data and analytics data on the same OLTP database. Unfortunately, an OLTP database is not designed for fetching the massive volumes of data for such analytics queries. At some point, a long-running database query for some analytics use case may impact the performance of the database while handling real-time operational data. Not the best approach. Maybe it's feasible to simple use cases. The second option is to use one or more OLTP databases for operational data and another dedicated OLTP database for analytics data. In such architecture, the workload on one database system will not impact the workload on the second database system. This workaround is working reasonably well for simple analytics requirements. However, during the years, the requirements for handling more complex and faster analytics queries pushed the market to develop new technologies that can better satisfy analytics application. And now we are moving to the third option. Those new systems are called online analytical processing, or in short, olap. olap emerged a bit after OLTP as enterprise companies realized that they need a fast and flexible access to the data stored in their OLTP systems. So the idea will be to take the data from each OLTP system. Imagine 10 different OLTP systems in some organization and copy that data into a different database that is more olap oriented. The data will be stored in a different structure optimized for analytics queries. This new structure is based on multidimensional database structures known as cubes in the olap terminology. Unlike OLTP systems that stores records in a simple two-dimensional structure, which is more relevant for transactions. Now, where this kind of analytics data is stored? Well, such data is stored in a dedicated centralized database called a data warehouse. And let's talk about the concept of a data warehouse in the next lecture.